So today we consider equations with fractions, and the following example will be taken. In our previous examples, we see that if you want to remove a coefficient, if it is only coefficient that is remain with your variable, with your letter that you want to find value for, what you do is to divide both sides by the coefficient of that letter. And also, if you have things like equations such as maybe 2x minus 5 equals to 9, to solve this, around the variable you want to find, this letter, there is coefficient, there is this term too. So what you do is that it is this term you first move away in the name of collecting like terms. You move it to the right. And the moment it gets to the right, positive 5 will become negative. Negative 5 will become positive 5. Why? Because it has jumped over this equal sign. So you will have on the left, you have only 2x left on the left side of equal sign. You now write your equal sign like this. On the right side, you have 9. So that negative 5 will come and join 9 on the right and becomes positive 5. So this will give you 2x equals to 9 plus 5 will give you 14. Since it is only coefficient that you have left, anytime you are removing coefficient, you divide both sides by that coefficient. That is, since the equation we have here is 2x equals to 14. Both sides means the two sides, the left side and the right side. Why we divided both sides by 2? Because 2 is the coefficient of x. And coefficient means something that multiplies another thing. For you to detach that thing, you do the opposite of multiplication. Since between 2 and x, there is invisible multiplication. So it is only division, through division, that you can remove it. And this will take care of each other. You have x left. That means you have achieved your aim. 14 divided by 2 will give you 7. So this is the value of x for that equation. And you can see that in this equation, if you want to test whether your answer is correct, come back here and say 2 times x. Since your x is obtained to be 7, 2 times 7, 14. Take away 5 from 14, it will give you 9. That means balance is correct. So today, we move on to another aspect of equation. That's the one that involves fraction. And we can see that the fraction we have in each of these is a single fraction on both sides. It's a single fraction on both, or let me say on each side of equal sign. So the first one says you have 5 over x equals to 2 half. 2 half means 2 as a whole number, and this fraction 1 over 2 half. First of all, what you do is this one, let it be in a single fraction, not, let it be as improper fraction. And when you have a mixed fraction such as this, maybe you have 3, 2 over 5, and you want to change this fraction to an improper fraction, do you know what to do? If you want to change this one to an improper fraction, do you know what to do? Okay, what you do is that use the one down, we call it denominator. You will still be taught fraction. The one down denominator, use it to multiply the one here. That is whole number. It will be 5 times 3, that is 15. 15 plus 2, that is 17. Then over, you write the original denominator, the one down. So if I give you this one, can you help me change this to an improper fraction?
Okay. So 5 times 4 equals 20, and 20 plus 1 equals 21.
Over 5. Very good. So everything that your results will still be over the original, the number down, the number at the bottom, which is 5, we call it denominator. you still put original denominator there over 5. So if you want to convert this one back to this, you will just say, how many times can 5 go in 21? 5 times 4 is 20. 5 times 4
Yeah.
is 20. So 5 can go in 21 4 times successfully. But there will be remainder. We'll have remainder 1. That remainder is what we put here. Then you still write original denominator, the number at the bottom. So over 5. Now, that's what the idea I want to employ in that A. For this A, we're already given 5 divided by x equals to, can you help me convert this one to an improper fraction?
Five divided by x
No,
is
no, 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 no. This right side, look at my cursor. Look, this right
oh
side. Convert it to improper fraction, what we just did.
okay. So, two, um so this will be 5 over 2
Okay, that's correct. How did you get 5 over 2?
because I times 2 which gave me 4 and I added that 4 with the 1
Okay,
so
that's
that gave me
correct.
5.
Okay, that's correct. Now, the next thing we want to do is, you see that on the left of equal sign, we have just one fraction. How do we know it's one fraction? Look at this fractional bar. It's just one that we have on the left. And you can see that a single denominator. It's either you look at the line or you look at the denominator. How many denominator do we have? It's only x. On the right, how many denominator do we have? It's only 2. So anytime you have a single fraction on each side and there is equal sign in between them, we call it a fractional equation. And since it is a single fraction that we have on each side, for us to clear the fraction, it's just like if you still have apple on its tree, until when you pluck it, if it is not plucked, you won't be able to, you know, access and eat it. So you first pluck it. So this fraction now, we need to clear this fraction before we think of maybe we want to collect items or we want to divide both sides. So how do we clear this fraction? We now do what we call cross multiply. You will say cross multiply. Can you tell me why are we cross multiplying?
Um, so we're cross multiplying 5 times 2, or I mean 5 divided by 2. Wait,
I didn't ask you to solve it. I said why? Why did we say cross multiply? Just like if I say why are we dividing both sides by coefficient, you will tell me that why are we dividing both sides? Maybe we have 2x equal to 6, and we say divide both sides by 2. If I ask you why are you dividing both sides by 2, you tell me because that 2 is the coefficient of x. But this one I just explained the reason why we cross multiply to solve fractional equation. I said the reason why we cross multiply is for us to be able to clear fraction. In order to clear fraction. That's the reason I put in parentheses. In order to clear fraction. So that's the reason. Anytime I ask you, that's what you will tell me. We clear fractions so as to clear, we cross multiply so as to clear fractions. We don't want this fraction to still remain. We want to remove the fraction. And for you to remove fractions, you cross multiply. Is that taken?
yes.
How do we now cross multiply? Look at what you do. Look at
Okay.
this left side and this right side. See the two as I told you, the left side sees as one country, the right side sees as another country. So the down, the one, let me say this left side is let's use two countries now. So let me use Nigeria and Ghana. Nigeria to the left, Ghana to the right, and the border between them, the boundary is this equal sign. The one down here, Nigeria will go and multiply the number up in Ghana. And the number up in Nigeria will come and multiply the number down in Ghana. Do you get? Up here will multiply
Yes.
this one, down here will multiply that one. So that means you always have the boundary between them, the equal sign. So to the left now, I will say x times 5, and I have
It was 5x.
that is 5x. And to the right, what do I have there?
10. 5 times 2 is 10.
That is 10. Any problem with that?
No,
Okay.
no.
Now, if you now have 5x equals to 10, tell me what statement do we make? Use your previous knowledge. In the previous
So,
equation, we have done something like this. What do we say?
we will divide both sides by 5.
Very good. Divide both sides by 5. That's the coefficient of the letter we want to find, coefficient of x. And of course, suppose it's multiple choice. By now, you should know what your answer for this x will be. You know this x starts from something. 5 times something equals to 10. What is that something? What do you think it should be? 5
2.
times some, that is 2. But for you to get this now, you just say, since we have 5x equals to 10, divide this side by that 5, divide this side by that 5. Do you get? Because the two of them multiply, you reverse, you do the opposite, which is division to remove it. So when you do that, this 5 and this 5 will go, and you have x left, which will now give us positive divided by positive is positive, and 10 divided by 5 is 2. So that means x equals to 2. Let's quickly copy that.
Well, well, I'm done.
All right. We move on to the second one.
Okay. Oh, it's cold.
The B part requires that we solve equation reciprocal of A, that is 1 divided by A equals to reciprocal of 3, 1 divided by 3. If reciprocal of A, even without solving this, if reciprocal of A, that is 1 over A equals to reciprocal of 3, that means A itself is that 3. Because look at this one we have here, 1 up here and 1 up there. 2 down here, A down here and 3 down here. That means if up and up are equal, then down and down should be equal. That means A should be 3 in the first place. But since we want to show our workings, you first tell me, what do we do first? To clear fraction, what do we say?
Um, so, so, um, so, so, in order,
What
in,
statement do we write?
um, in, um, we,
You need to learn this. You know, the other time when we wanted to remove coefficient, you are the one that told me divide both side by 5. So when you see fraction,
oh,
first of all, you think of clearing that fraction. What statement do you make to clear fraction? You say cross multiply. Don't forget cross multiply, because I will still ask you cross multiply. It's very important that you put your attention on it so that you get it next. So cross multiply. How do we cross multiply?
so, okay, so, So it's like that A is going to be towards the 1 and the
Okay,
1 is going to be towards the 3.
very good. So this A will go and multiply this one, and this one up here will come and multiply this 3. So that will give us A times 1, then you put equal sign between 1 times 3. And we now have
Oh,
A
okay.
times 1 is A. A times 1 is A equals to 1 times 3 is 3. Since what they asked us to find is solve this means find the value of A, and we already have that A as 3. So you stop there. That's the answer. Is it clear?
Yes.
Because if you look at the question in the first place, they said 1 divided by something gives 1 divided by 3. So indirectly, they are implying that that something is 3. And that's what we've obtained here. Let me know when you are done writing.
Oh, I'm already done.
All right. So for C, 3 over 2y equals to 1. Now, fraction is fraction. Anytime you want to remove this, you must ensure that you change each side to a fraction. So this one is still 3 over 2y equals to 1. So this one now, we want to change this to fraction, it will be 1 over 1. You know, anything over 1 is that thing. If I have 7, 7 as a fraction is same thing as 7 divided by 1. Because 7 divided by 1 will still give me back 7. But for the purpose of having a temporary fraction here, so we'll write, if you have ordinary whole number, write it as, write the number as over 1 to convert to fraction. So that you can now say, what do we now say to clear fractions?
Qua- we cross, we
Multiply.
cross, yes.
We cross multiply. So cross multiply. And if I ask you, why we cross multiply? Because we want to clear the fractions.
Yes.
We want to remove
Yeah.
the fractions. Okay. So, and to cross multiply demands that we, these are the one up here, this 3 will come and multiply this one. And this 2y will multiply this one. Is that not?
Yes.
So we now have 2y multiply 1, then you put equal sign. This 3 will come and multiply 1 here. 3 times 1. So this will eventually give us 2y times 1 is what?
2y.
2y equals to 3 times 1.
3.
Very good. Now, what's the next step? What do we do next? Or what statement will you make next?
We're going to divide both sides by 2
Very good. Why? Because 2 is the coefficient of
of
y.
y.
And when we do that, we will have 2y over 2 equals to 3 over 2. You divide each side. Divide this side, this 2y by 2. Divide this 2 by 2. Because in equation, the thing is already balanced. So whatever you do to the right, you must do it to the left. And this
So,
will cancel this. So you now have y equals to 3 over 2. That's your answer. Or the equivalence. The equivalence of this is when you convert it into mixed fraction, just like we have here in this number A, example A. So if you want to convert this to a mixed fraction, you say 2 goes in 3. How many times? It can go 1 time.
Yeah.
You still have 1
So
left, remainder 1. That remainder, you write it, then all divided by the original number,
3
the
times.
denominator, which
So
2.
3 whole number 1/2.
So if you need to convert this one back to 3/2, what do? Look at this. To convert this number back to 3/2, you know this one is, we call it mixed fraction. What do you do to convert it back?
Mixed fraction.
It's called mixed fraction. How do you convert this mixed fraction back to improper?
Oh, um. So do we?
You will say 2 times 1, which will give you
Oh,
2. Then you now add the top number. So 2 times 1,
oh,
2, plus 1, 3. You get this 3, then everything over the original number over 2. When you are done there, let me know. So we go today.
oh well. I'm already done.
Okay.
Lord,
So for C, oh, we have done C, sorry. We go to D. For the D part, we are giving x minus 1 over 21 equals to 1/3. 1/3. Look at this. The whole of this one, is it a single fraction or not? The left side of equal sign. Is it a single fraction we have there or more than one fraction?
um. This is more than one fraction.
Check. How many denominators, the number down, do we have on the left side of equal sign? How many denominator?
One.
It's one. It's just one figure. If it is one denominator, that means just one fraction that you have there. And you can check this fraction line. It covers everything. It's just one fraction bar that we have here. So it shows that the whole of this expression is just a single fraction, just one. Then if you look at the right side too, this one is obvious enough. You can see a single line and a single denominator. So it is one fraction we have on each side. And when this happens, and you need to clear the fraction, what do you say?
Um, we cross multiply. We cross multiply.
Very good. We cross multiply. And to cross multiply, can you tell me what to do? How do we cross
Mm,
multiply? How do we cross multiply?
Well, usually we force multiply them in straight arrows, but those two.
Which and which we multiply? When you cross multiply, at least we have done A, B, C. This is D. So how did we do those ones? How did we cross multiply?
Um, oh, so we so we
I
so
expected you
that's
will tell me that 21 will go and multiply that one. 21 will come to multiply. 21 will come to multiply this one. And the one up here, x, this x minus 1. We come and multiply this 3. X minus 1 will come and multiply this 3. Y 21 will go up to multiply this 1. That's what you do there. When you are cross multiplying, the number at the bottom of the fraction, on the left side of equal sign, will come and multiply the top number at the right side, on the right fraction. So this is the right fraction now, the fraction at the right side of equal sign. The top of it will multiply the bottom of the left fraction, while the top of the left fraction will come and multiply the bottom of the right fraction. You just cross them like that. Do you get?
Yes.
Okay.
Yes.
Now I want
Yes.
you to know something again, that if you are multiplying, suppose we have 3x and it's to multiply 4, you are free to use this sign to show multiplication. But if you have something like 3x, maybe plus 6, and it's to multiply 4, don't do this. Don't say times. That is wrong. So instead, you use parentheses. That 4 will multiply. You put 4, you put the parentheses and pack this 3x plus 6 inside the parentheses. Why? Because this one is not a single term. 3x is one term plus positive 6 is another term. So since you want to use 4 to multiply more than one term, we prefer to put parentheses, the brackets, to indicate that. So don't put times there. If you put times there, you are implying that this 4 is going to multiply just positive 6 alone and not 3x. And it's meant to multiply both of them. So the use of these times in that case is not correct. So if this 3 will multiply both x and negative 1, do we use conventional times, this sign, or we use brackets to show the multiplication?
Yes. So we want to use brackets.
Very good. So we now have this 3 to multiply x minus 1. I deliberately first multiply the one with x so that I can have it on the left. Or if you like, you can multiply 21 times 1 first and write it before you now multiply that one and have it to the right. It's still correct. So since you have multiplied to get result on the left, this 3 has multiplied this. The next thing you do is to allow this 21 to multiply this. So you have 21 times 1. You have cross multiply. You can see now after cross multiplying, there's no fraction again. There's nothing like something over something again. So the next thing we do is to clear brackets. We clear brackets, clear the brackets. So we want to open the parentheses. So we have to open these parentheses. You use these 3 outside to multiply everything inside, isn't it? So we have
Yes.
3
Yes.
times x, you have 3x,
X.
and 3 times negative 1, you have negative 3.
Um,
So you now say equals to 21 times 1 will give you 21. After then, what do we say?
oh. Yes. Oh. After this,
You
we
collect
are
like
going.
terms. Collect like terms. Move that negative 3 to the right. You need to work on this aspect, please. You need to work on this. Try and watch the video, all the videos sent to you on this concept so that you remember everything. Collect like terms. So we now have 3x equals to 21. That negative 3 on the left will go to the right and becomes plus 3. And you now have 3x equals to 24. So from here, the next thing we do is, since it is only that coefficient that remains there, so you divide both sides by it. Divide both sides by 3. And we eventually have 3x divided by 3 equals to 24 divided by 3. And this will finally give us, because this will cancel this, x equals to 8.